Is the second edition of Podcast Sundays. Last week we had Assad, and now we have Sandy Maguire. So what do we know about Sandy? Let's do a short introduction, right? Or what do I know at least? And maybe Chet, you can contribute if you think I've missed something. So I'll start from recent maybe, because recently he like I think it was even on this Monday or something like that. He released Algebra-Driven Design. I've been following it ever since. I think ever since he restarted his Patreon, I've been supporting the book because it seemed very like a very good topic to me and something that close and dear to my heart. But I've not read it until now because I've done that with Chris Panel's optics book, and I read it early and then I didn't have time to reread it, right? So I wanted to wait for it to be at least close to done or done, and then rereading it. And I think I've read the introduction, the first chapter so far since it was launched, and I'm absolutely loving it so far. So I'm really looking forward to reading the rest of it. Then also probably most of you already know he wrote the Thinking with Types book, which I've also read, and it was absolutely amazing. I probably need to go back to it because the thing with like type level programming, and I'll probably cover this with Sandy, is that like you do the exercise, you learn it, but then if you don't use it often enough, then you kind of like lose your edge, I think. So then he's the author of Polysemy, which I think sparked some interest in that area, and then some other libraries are coming up. But I have also seen some traction with Polysemy on Zolip at least, so that's also pretty awesome. And then he also has has his what was it called? I was actually going through some of his blog posts here. What is it called? Project Erdos, right? The Erdos project, which is something that's also super fun. So yeah, we'll talk about all of this hopefully right now. So let's swap scenes and say hi to Sandy. Hello, can you hear me?
Yeah, hi. How are you, lad?
Hey, welcome. Well, I'm great. I think this is the first time I'm a bit like I have a bit of I know, like I'm a bit starstruck in a way, right? Even though we've talked a lot on on chat, I still like I love most of the things you've done. Or I mean I should say everything because I don't have any example of things that I like. I'm not sure about that, right? So. Yeah, I've been looking forward for today. I'll be honest, because I'm looking forward to pick your brain about a lot of things. So yeah, how are you?
I'm excited to be here.
Cool, happy to hear it. So how are you? How are you today? How's like? So let's start with like recent, right? So how it's finally getting done with the book, right? You're finally done. It's out there. So how does it feel?
It's amazing. It's not entirely 100% done. And so I'm currently waiting on a foreword. And then I realized in the book called Algebra-Driven Design, I didn't once describe what an algebra was. And so there's a hot fix coming in the probably next couple days. And then at that point, I'm going to sort of do a more formal announcement.
Okay.
So, but I guess to answer your question, I'm feeling great, man. Feeling incredible. It took about a year to write this book. Which involved like 3 complete rewrites. At first, it was sort of a book about free monads, and then like a style guide to Haskell or something. And turns out if you keep rewriting the book from scratch, it takes quite a while.
And that makes sense. But I also love that about the process you've been doing, right? Because you're not like, okay, I want to say this, and then I'll figure out the examples such that I will end up saying what I want to say beforehand, right? You're ready to start from scratch whenever you found that, okay, I found a better approach, I found something different, right?
Yeah, absolutely. A lot of the experience was sort of writing it and then realizing I had no interest in reading this thing I was creating. And I think it's really important to create things that you yourself want.
Yeah, that's pretty cool. Okay, so I don't know. Since we've started with algebra-driven design, let's dive into it a bit. So,
sure.
So how did you come up with the idea? Like, was it just an iterative process of writing the book, or how did that went?
So I think the primary idea came from a paper by John Hughes called. I'm blanking on it right now, but it's deriving a pretty printing algebra, I think it's called.
Okay.
Yeah. I'll double check the title of that later. But he sort of describes the Hughes PJ printer that's available in the Pretty package, and it's talks about how to do pretty printing.
Okay.
And something he really mentions in like a quote in the paper that really resonated with me was that this is a hard problem, and because of it, nobody solves it. And so everybody just writes bad printers. So his strategy was, I'll just write a library that does it for you, and then everybody can import it. And I just love that attitude.
Cool.
And yeah, so in the paper, he sort of talks about like, what do we want out of a pretty printer? Like, what does it even mean to build a good pretty printer?
And he has an approach similar to the book, like that's where you got the idea, or?
That is absolutely where I got the idea. It's a gold mine of a paper. There's just so many great ideas, and unfortunately, there's only one example. And so, a huge part of the process was me like reading and rereading and rereading this paper to try and like understand all of the things left unsaid, sort of between the lines. So that's where most of the inspiration came from, as well as Connell Elliott has a thing he does called denotational design, which is a very similar idea of sort of asking the question, what is it that I'm trying to build before you start building it?
Although I think he focused a bit more on the model and on the like rather than the laws, from what I've seen. Although he does talk about the laws as well, but
I think his laws are all turned out to be homomorphisms, like type class homomorphisms, but. Yeah. So anyway, the combination of those two factors was just it really seemed like these guys were onto something, and especially like something that we seem to have lost as software engineers. Maybe we're just too eager to jump in and start implementing things without, we'll figure it out when we get there.
That's interesting. So do you think when you say lost, do you think like we had it before, like the elder programmers who were doing it this way, or?
I mean, it's hard to say, right? Like it's quite evident in the literature, but it's, those are not the typical programming guys. So most of the papers I found on this subject were like written in the 70s. And it's like, oh, like I'm doing absolutely nothing new here, right? Like,
and doing archaeology, not discovery, right?
Yeah, exactly. And so it was a little frustrating to say, oh, like everything I think that is new is at least 50 years old. But on the other hand, for better or for worse, I think that academics are quite bad at exposing their ideas to the greater world.
Yep.
And so I sort of look at maybe my role as
well, they're usually not incentivized to do that, right?
Absolutely. Yeah, absolutely. I don't fault them for it, but I think it is a flaw in the system.
Yeah. Okay, cool. Well, and I also think like they didn't have all the tools that we have right now, right? So the languages that are available in the 70s and 80s and so on were like, it was a lot harder to do FP. It was a lot harder to have a good checked type system for FP, to quick check, to have like all of the things that are needed to be able to like check the laws, and to like a lot of other even provers, right? They weren't provers like as good as today, right? Because I assume that you could even write those laws, throw them into Agda or whatever, and then try to play with that. If you need to write code, right, that would probably be a better place to play with the laws than.
I think that's actually very insightful. That like writing code might have just been harder in the past, and so they needed better tooling, at least like better structure. So. Unfortunately, I think it's still a thing we've lost, right? And,
sure.
Whenever I try this, it's amazing how much better the designs get.
Cool. Well, I'm looking forward to see what the other chapters are, the other examples, and the rest of the code. But
cool.
that sounds super interesting. Well, let's circle back, and then maybe we'll get back to the book later. So one thing I'm always super curious about is how did you get into FP, right? What was your journey? Because like we were in a kind of a fringe place, right? It's definitely not the mainstream thing to do, right? Getting into Haskell and FP and so on, right? So what was your journey?
In university, I had a lot of internships, and sort of everybody in my program had a lot of internships. And so one year, or like one summer after an internship, my friend Sanjay came back from Twitter, and where they started using Scala, and he was sort of raving to me about flat map and all these things. And I don't think he knew that it was functional programming. He just sort of knew that like it's so much better than writing loops.
Okay.
And at the same time, I had a friend named Alex Klen, whom we called Dr. Monad. And he was like the only Haskell person in town, as far as I could tell. And as Haskell people are wont, he would not stop talking about it.
Fair enough.
And so Alex set me down for maybe a few hours and sort of explained Haskell. I didn't really understand it. And so my next summer, I was working at some company and just didn't feel like working for the day. So I pulled up Learn New Haskell and didn't program along, but read it and was sort of amazed. I especially remember being amazed by the dollar operator, right, which is just defined in library code. And it lets you get rid of parentheses. So that's sort of mind-boggling. And so that was mostly it. And then at some point for my final semester of university, I had a class on AI. And in that class, the final exam was sort of written pen and paper, but you were supposed to write code. Okay. And my strategy was I figured that, there's no way they're going to type it out and compile it. And so I assumed that if I chose a language that the markers didn't know very well, they'd probably be more lenient with me. So I picked Haskell, which I had some exposure to, but never written, and sort of ramped up on my Haskell skills just in order for that exam. It turned out I loved it, and I don't think I haven't gone back.
Okay, so from there onwards, you've only gotten Haskell jobs, and you worked with Haskell, or did you?
I had one job writing C++, sort of that I signed the contract for, and then I got like good at Haskell in the meantime before I started the job. So my first day I was like, oh, I've made a huge mistake. So I think I made it at that company for 53 weeks on the dot. Just enough to keep the signing bonus.
Okay, yeah, fair enough. Okay, interesting. So that's how you got into Haskell initially. Yeah. But then I guess how did you so your learning process was just going through learning Haskell and then trying things out for yourself, or like how did you get in? Because a lot of people maybe get stuck on learning Haskell, or a lot of people needed like other books, maybe Haskell from first principles, because it's like the tome, right, where it's a lot bigger, a lot of exercises. Did you just dive in and try stuff yourself, or how did that work for you?
I just started writing games. It's sort of my strategy for learning any programming, which is to try and write a video game in it, because you run into all these non-trivial problems immediately. And then it's like, how do you do this? In addition, I had a friend named Vikram, and he was also sort of learning Haskell at the same time. And so we would pose little problems for each other. And so I'd send him a type signature and ask him to implement it, and then he'd send one back. And we played that game for a few months of just like maybe 5 a day, just trying to implement things based on the type alone. And it's sort of amazing just how quickly you get good at it when you do that sort of exercise.
Yeah, and then you have somebody else who's kind of acting as a motivator, right? Because you don't want to quit because they're also into it, so you kind of motivate each other, I guess, when doing that. Cool. Vince asked in chat that would you say that academia helped you with getting into Haskell?
Not at all.
Blunt, nope.
No, I didn't learn it in university, or my university was really focused as being a feeder school for getting a job in San Francisco, and so it was entirely focused on practical algorithms and data structures and writing fast loops.
That sounds like they're preparing you for the interview more than the job, actually. But
I think that's probably true, yeah. And so the university boasts extremely successful numbers, but at the cost, I think we lost out on a lot of the interesting CS stuff as opposed to the engineering stuff.
Okay, I get it. Right, so not a lot of abstraction, not a lot of logic, general computer science. They were kind of on the backside, I guess, right?
Right. In fact, I think Haskell has gotten me better at academia rather than the other way around.
Yeah, that's totally true for me as well.
Because sort of the culture is read this paper, read that paper. And I don't think I'd ever read a paper before getting into Haskell, and now it's a few a week, right?
Yeah.
So for better or worse, maybe Haskell is that tool to get people in academia.
Yeah, that's yeah, I totally agree with that. I've never voiced it like that as well as that, but I definitely agree with it. It's almost like it's my own idea. Is that I resonate with that also. Cool. So let's see what other things do we want to talk? Well, let's do the Erdos experiment, because I think that's super interesting, at least to me. So maybe tell everybody what it was about.
Sure. So I was living in Ottawa, Canada, which is the capital of Canada, but it's not an exciting capital. And it's like very quiet and governmental and sleepy. And it's not a good place to find sort of tech people.
Okay.
So I was there for a year and just felt like my intellect was melting from sort of lack of stimulation. Like internet friends are great, but it's so much better to be able to hack in person or talk about these things in person. And so after a year of that, I just was feeling trapped, and I thought that I needed to get out and first of all, get out of Ottawa and also go meet interesting people. Okay. And I thought it might be a good idea to combine those into one. So I posted a forum to a bunch of websites that are Haskell related saying like, hey, I'd like to come sleep on your couch. If you're interested in having me, I'm going to force you to like hack on projects with me. And, let me know. So I think I got something like 400 responses to that.
Whoa, that's amazing.
It was insane. It was more than 2 years worth of couch surfing if I wanted to take it.
Wow.
In like every continent, I guess except Antarctica, but
not a lot of Haskellers there, I guess.
Not a huge amount of them, no. Yeah, and so I set off with a single suitcase. Sort of the name of the project is after Paul Erdos, who lived for like 70 years on the road. He had 2 suitcases, and he'd pick up and show up at mathematicians' doors. I'm invited, and he'd knock on the door and said, "Hi, my brain is open, and let's like write some papers together." So I think in total he wrote like 10,000 or 1,000 papers. Yep. Just over the span of his career, and it was just like showing up and doing a lot of drugs and just working on math. I wasn't doing the drugs, but I think by the end I really understood why he needed it. It's exhausting to couch surf for so long.
Okay. Oh, because you're always on, right?
You're always on, and you're always on other people's schedules is the other thing, right? It's just like you're always sleeping on the couch, and you're always waking up when other people are, because you don't want to be a bad guest. Because if you are a bad guest, that's the end of it, right?
Sure.
Yeah, so I did that for about 4 months, and I think I met maybe 20 or 30 people.
Okay, that's a lot. Yeah, that sounds like a lot of work.
It was a huge, I was so exhausted by the end, but met a lot of like really fantastic humans, and I learned a lot, and I think that they probably learned a lot as well.
Cool. Yeah. So we want to share a few stories that stand out to you, or?
So maybe one of the best experiences I had was in Toronto with a guy named Jonathan Lorimer, who he had this idea of let's build a GraphQL library in Haskell.
Okay.
And I had just come off the type level programming train and might have taken it a little too far. But yeah, the idea was sort of you give us a data type and we will generate all of the machinery automatically for it.
Cool.
And so that was like a really great project. And Jonathan is an amazing guy. Just like, I think out of everyone I visited, he was the only person like willing to put in multiple 14-hour days.
Wow.
Which is really what I was looking for, right? Like that's sort of the amount of time I like to program for. And it was sort of challenging to convince other people of that. So I was just like amazed of just how eager Jonathan was to learn and to make things.
And of course he's in chat, so he just said, "Hey, what's up?"
Hey, Jonathan.
Yeah, I was gonna say that I've seen him a couple of times in chat, and I was wondering if he's here, but I didn't want to call him out and ask. Right. Cool. So Sandy put in an 18-hour day though, which was nuts. Okay. Cool. Okay, so I think you also, like from what I've read, you've also spent some time with like Songer case, which again sounds like that was fun, right? Or am I misremembering?
Yeah, I didn't stay with Chongur, but
oh, you just met him with him to do some work.
Yeah, we went out to the bar a few times. I went to his office a few times.
Oh, okay.
Yeah, there was talk of me doing a PhD sort of alongside him, and so there was partly just syncing up for that, but that never panned out.
Okay, cool.
Yeah, working with Chongur is like a delight. That guy is
he's like brilliant.
Really,
right?
truly, he's one of the smartest people I've ever met, if not the smartest. And like I was starstruck the entire time. Just like, oh god, I don't look like an idiot beside Chongur.
Yeah. And he's really young, right? Despite being like, I think, right? Because he's or am I
he was very young at some point. I think we've all gotten old, you know?
Well, maybe. I guess so.
Yeah, I think he's in his early 20s, which is like he's so much more accomplished than I was at that age. Arguably more than I am now, right? And so that's so I'm just waiting for him to drop the unsaturated type families, which he's been talking about for years, and so I'm going to call him out on the stream. Chongur, get it done. We all need it. Oh
yeah, I think quite a few of us have been running that GHC version, like the home built GHC version, just to play with it, right? So I'm definitely one of those people. So yeah, that's definitely fun. Yeah. Okay. Cool. So